So let's start with this section. If you check section 5.2, they're telling you the area because it's the beginning of the area rules. But the first thing we're going to learn, the sigma notation. When you hear sigma notation, let's see what does that mean. The sum of n terms. So if you have n numbers, let's say from 1 to 100, how much is going to be the sum for these numbers? If you add 1 plus 2 plus 3 plus 4. So the sum of n terms, a1 until an, written as. This is called summation, which is the sum. So the summation of ai, and I started from which number? From 1 to n. So if you plug in 1 here, it's going to be a1. If you plug in 2 here, it's going to be a2. If you plug in 3, plug in 4, if you plug in n, the last term is going to be an. So from the first term to the last term, okay? It's called the summation, which means the sum of n terms, okay? I is the index, let's say the beginning points, the first term, started from a1, index here is 1, 2, until n. That's what we call I is the index. S is the summation, which is the sum of the terms. N is the bound, which is the last term, okay? So the summation from the first term to the last term. That's the important rule here, and there is a proof for each one. If you check the slides on Canvas, you will see a proof for each one. We're not gonna check the proof, we're gonna use the formula. The first one, the summation from I1 to n to the constant to any number like 7, 6, 5, 2, -2 is going to be the number times n. You can flip it. Write it down like this. Cn or nc. So this is the rule. Every time when they ask you find the summation of a number, it's going to be the number times how many terms? From 1 to 5, so it's going to be c times 5, okay? Now, if we have summation to the same index, so it's going to be n plus 1 divided by 2. This is the second formula, and we're going to use it. Now, if we have summation from I1 to n, I squared is going to be n plus 1, 2n plus 1 divided by 6. So every time when you see exactly the same, you're going to take this one and you're going to plug in what exists here. Okay? I cubed, here's the formula. This is important. Number 5, if we have a number times ai, can I take this one out of summation? Yes, by using this one. And there's a proof for that. We're not going to use the proof, we're going to use the formula. The number k, summation from I equal 1 to n, ai. The next one, if you have summation to two terms, ai and bi, you can take the summation for the first one, plus or minus summation for the second one. We're going to use these rules. It's 6 rules. Before we jump into the next board, let's do some examples. So check the first one. What are they telling you? They're telling you to write down the summation for this one, which is going to be equal. Now, the first one, k equal how much? K started from which number? To 3 until 6. That's when we have a 3, 4, 5, 6. So first of all, I'm going to plug in k equal 3. That means it's going to be 3 over 3 plus 2. Plus the second term is going to be what? Plug in k equal 4. So it's going to be 4 over 4 plus 2. The next term, plug in k equal 5. So it's going to be 5 over 5 plus 2. Then from a 3 until which number? Till 6. So 6 over 6 plus 2. Because check here, we have how many terms? The index, be careful. Sometimes the index K, sometimes the index I, don't confuse yourself. Always the index starts from this number and goes, this is the last term. So the index starts from 3, 4, 5, and end until 6. This sign is called summation. That means the summation of these terms. So it's going to be 3 over 5, which is a plus 4 over 6, plus 5 over 7, and the last one plus 6 over 8. That means you have to add these numbers and you're going to get the result. It's a fraction. You can add these two first, and then you're going to add these together, and it's going to be a really big number. Okay, so it doesn't mean you are wrong. Okay, like 1,000 something. But you get the point. You have to, if you want to add these two fractions, add these together and add these together, and the result just add as a fraction. And you get the result. Okay. Any questions so far? Now, can we do the opposite thing? We have this side, and we need to write down the summation. This is also important. Now check. The top number, is that fixed? 3, 3, 3. So it's fixed. With the formula, I'm gonna say, okay, it's just a 3 here. Okay, because 3, I have with the first term, 3 with the second term, with the third one, with the fourth, with the last one. Now, 2, and I have 2 here, I have 2 here, and I have 2 here. That's mean I have plus 2 here. Now, which index you want to use? You want to index I equal. Check the number here. 1, 2, 3, and keep going until 11. That means start from 1 until where? Until 11. I'm going to put 1 right here. So now, when you plug in I equal 1, it's going to be 3, 1 plus 2, the first term. When you plug in I equal 2, it's going to be 3 over 2 plus 2, which is the second term. When you plug in 3, it's going to be the third term. Plug in 4, the fourth term, and keep going to the last one. So it's going to be 11. 11 plus 2. You get the point? How to work on this one? This one is the summation. We have to write down the terms and how much the result. This one, we have the terms, and we need to find the summation. Can we do the same thing with the next one? Check how many times. From 4 to 8. That means this one is going to be equal. The first term is going to be 1 over 4 squared plus 4. Plus the second term is going to be 1 over k squared. So I'm going to use 5 squared plus 4. Plus next term is going to be 1 over 6 squared plus 4 plus 1 over 7 squared plus 4, and then it's going to be equal 1 over 8 squared plus 4. This is a plus, not equal. The last term. That means it's going to be 1 over 16 plus 4 plus 1 over 25 plus 4 plus 1 over 36 plus 4 plus 1 over 49 plus 4 plus 1 over 64 plus 4. That's when you're going to add 1 over 20 plus 1 over 29 plus 1 over 40 plus 1 over 49, it's going to be 53. It's 1 over 64. Six 40, 29. Okay, and you're gonna add these numbers. Now check this one. And I'm telling you, we're gonna use the formulas. Summation from 1 to 24. That means we have 25 terms, and we need to find the sum of these terms. But check here, and be careful, we have 6. So now, with the 6, can I move the 6 outside the summation? So the first step is going to be 6 summation from I equal 1 to 24, and the left is I. Now, the second step, here is the 6. Now, we have formula. It says summation from I equal 1 to n to the I equal 1, and n plus 1 divided by 2. So here is the formula. Now, how much n I have? 24. So it's going to be 24. 24 plus 1 divided by. That means I cannot plug in instead of this part is going to be 24. 24 plus 1 and divide by 2. That means it's going to be 6. And here is going to be 24 times the 25 divided by 2. Simplify these two. It's going to be, here's a 3, and here's 24 times the 25. So if you multiply, you got it? You're gonna tell me the first step. Always look, do you have a number you can take it out? Make everything easier? Like a constant number? You can do anything with the 4, you can do anything with the 7 for now. But 1 over n squared. N squared is the last term, right? So it's a number. Can I take 1 over n squared outside the summation? Because it's a number, right? N is the last term. Like for example, if the last term is 60, so that means here it's going to be 60 squared, which is still a number. Can I take the number outside the summation? Yes. That means here is the first step. I can say, okay, 1 over n squared. Here is the summation from I equal 1 to n. And here is 4i plus 7. Now tell me, what's the next step? This is a number here. I'm not going to worry about that. What's the next step here if we have summation, this term plus this term? Which one I can use? You have summation of 2 terms.
So separate.
Separate the summation. That means rule number 6. I can say, okay, it's 1 over n squared. I can say, okay, it's summation to the 4i, I equal 1 to n, plus summation from I equal 1 to n to the 7. Now tell me, what's the next step? Here is 1 over n squared. I'm going to look to the first summation. The first summation, can I take the 4 outside the summation? So it's going to be 4 summation I equal 1 to n to the I. Plus, I'm going to keep this one for now to the 7. Now let's go to the next step. 1 over n squared. Here is the 4. What's the summation of I? Same thing here. Right? So I'm just going to plug in n plus 1 divided by 2 plus. What's the summation from 1 to n to a constant? What's the summation from 1 equal 1 to n to the constant? C times n. How much C?
7.
So it's going to be 7. Now what's the next step? You just have to simplify. can I simplify the 4 with the 2? It's going to be what? 2. That's mean is going to be 1 over n squared. And here 2n times n, 2n squared, 2n times 1 plus 2n plus what? 7n. Yes or no? Yes or no?
Yes.
What's the next step?
Fine.
Combine like terms. Can I combine like terms here? So it's going to be 1. What I'm gonna do, I'm not gonna write down 1. And I say it's 2 n squared plus 9n divided by n squared. Yes or no?
Yes.
So n squared for both these two terms. So is that the same thing? 2 plus 9 over n? Yes or no?
And then does that equal 0 or no?
No, that's it. You don't have to set up everything equals 0. That's mean the summation for this one as a rule is going to be this one. So here's the thing. If I'm telling you n equal 25, if I'm telling you n equal 25, you're gonna just plug in 25 where? Here. So it's gonna be 2 plus 9 over 25. If I'm telling you n is 1,000, you're gonna say, okay, it's 2 plus 9 divided by 1,000 is going to be the summation for this one. You got it? So here's how to simplify. We're using just the rules. Let's check this example, which is we're gonna do the same thing. Now imagine you plug in 1, it's going to be 1 plus 4 squared. Then you're gonna plug in 2, it's gonna be 2 and 2 plus 2 squared. Plug in 3, plug in 4, plug in 5. Now before we doing that, let's simplify. How are we gonna simplify? Can I use one of these rules? Can I say summation I and summation the parentheses? Do we have rules with multiplication? Because here's multiplication, right? Can we do that? So what are you gonna do? But we can't use one of these rules. What I'm going to do.
Can you foil the,
So this is, if you FOIL the parentheses, it's not gonna be wrong. You're doing right step. So on the side, I'm gonna say, okay, let's do it here. So it's equal, we're gonna keep summation from 1 to 6. Here is the I. If I FOIL this one, it's going to be I squared plus 6I plus 16. Yes or no? Yes or no?
how did you get 6i?
6 or 4?
I got 8i.
How we get 8? It's 2 times 4. So it's 8. So 8I plus 16. Now what's the next step?
Distribute the I.
Distribute the I. So here is the next step. I'm gonna say it's summation from 1 to 6. I times I is going to be I cubed plus 8I squared plus 16I. Now tell me what's the next step?
Separate them.
Because we have addition between two terms, so I can say it's summation to the first one, summation to the second one, and summation to the third one. So it's going to be summation from I equal 1 to 6 to the I cubed plus summation from I1 to 6, 8I squared plus summation from I equal 1 to 6, 16I. Now it's easier. Can I have rule for this one, so I'm just gonna say, okay, it's summation from I equal 1 to 6, I cubed. I'm not gonna plug it now. Why? Because I have this constant going out. Yes or no? So it's going to be 8 summation from I equal 1 to 6 to the I squared and plus the same thing here 16 summation from y equal 1 to 6. Now can I plug in? So the first one is going to be what? The I cubed, which is n squared, n plus 1, n squared, n plus 1 squared, divided by 4. Plus the second one, 8 with the I squared. So here is the 8. The I squared is what? N plus 1, 2 n plus 1. So n plus 1 and 2n plus 1 over 6 plus what? Plus 16 and n plus 1 divided by 2. That was the next step. Tell me what's the next step.
Stop it now.
But how? We're just gonna solve it. We're just gonna simplify. Like we're not gonna find the value of n because we already know n how much. What are you gonna do now? Because how much n?
6.
I have plugging just 6. So this one is going to be what? 6 squared. And here's 6 plus 1 squared divided by what? 4 plus 8. This one 6. 6 plus 1. 2 times 6 plus 1 divided by divide by 6. And here plus 16 and going to be 6. 6 plus 1 divided by 2. How much was it for the first step? Says there's something wrong. I cubed is n squared. Squared of n. So this one is going to be, just simplify 36. And this is 7 squared divided by 4 plus here is 8. This one is 6 times 7 times 13 divided by 6 plus here is 16 and this one 6 times 7. Just number you have just simplify it. So it's going to be 36 times 49, everything divided by 4 plus, you can cancel the 6 with the 6 from here. So it's going to be 8 times 7 times 13 plus, this one is 8 times 4, 2. Tell me how much it's going to be. To get 15 or 5. Cancel these. So it's going to be 9 times 49. And you're going to add, this is 56 times 13. And you're going to add with 8 times 42. Do you get this one? on the first day, we need to find the area between a line and a curve. Here's the line and here's the curve. So we say, okay, we're gonna divide the area to rectangles, okay? And now tell me. You can divide the area to rectangles. So now how many rectangles you can see? 1, 2, 3, 4, 5. Let's say we have 5 rectangles. I'm gonna get really approximate to the exact area by maximize the number of rectangle. Because if I did 5 rectangles, if I want to go more approximate to the exact area, I'm gonna take 6, 7, 8. So how many rectangles I can take to get really close to the exact? We can say n, okay? So we're gonna say, okay, n rectangles. We already know this is from A to B. So, okay, if I'm taking n rectangles, can I say it's summation? Now we're gonna check for the rectangle. We're gonna say summation from rectangle 1 to the n, okay? We're gonna take n rectangles for the whole area. From n rectangle 1 to rectangle n. For this graph, we have only 5, but I'm saying I need to maximize. I'm gonna take 6 rectangles, 7, 8, and keep going. Like the distance, the error is going to be smaller, smaller, smaller. Now, let's see. For this rectangle, it's a rectangle. To find the area, I know this is the width between 2 x points, x1 and x2. So this is the width for each rectangle. And the height, this is going to be the height for the rectangle, for this one. Let's say, I'm gonna say the height for this point is f to the point, when c, this is f to the c. So the height for this rectangle is c. Now I need to get for all rectangles. Can I say the height, you know the area for rectangle is length times width, right? For this rectangle, the length is what? Which is f to the c. And the width is what?
dx.
Dx. This is only for this rectangle. What about if I need to write down the length for all rectangles? Can I say it's f to the ci? Because if I say this is c1, this is c2, this is c3, c4, c5, that means the length is going to be f to the ci. Times what?
dx.
Dx is the same width for each rectangle, so times dx. Okay, so now we have this one. But do you know the number of n? We don't know the number of n. So what I'm going to do in this case, if n is 5, that means I'm going to take 5 rectangles. If n is 6, if n is 7, so I don't know how much the n. What I'm going to do in this case, I'm going to take the limit and approach the n to which number?
Infinity.
To infinity. That means I'm keep going with the rectangles and going to the infinity. That means infinity rectangles. You see, we're taking the limit to the infinity. So now we have limit and we have what? The summation. But we're not going to use this one. I'm going to give you an example how to find this part. But we're going to use remind sum to find the area, okay? But you get the connection. Now we have, this is the sum for our rectangles. This is the length of the rectangles and this is the width. We have the same width. Now, if I'm taking n to the infinity, that means I'm going to keep making rectangles until infinity. We're using the limit, so we're gonna get the exact area. Okay? So that's what we're gonna learn in the next section. Let's check. And that's the definition of the area, which says let f be a continuous and non-negative on the interval AB. The area of the region bounded by the graph of F, which is the curve, and by x-axis, and the vertical line x equal b. Here's the area is going to be limit when n approaches to infinity, summation f to ci delta x, and ci is between the 2 points, between x minus 1 and xi, and you know the delta x, which is the length, the width, sorry, b minus a divided by n. This is the width for each rectangle. So that's what we're going to use. And now, next example, we're going to do the same thing. The same thing with the summation, but now we're going to add the limit. So here's my advice. Keep the limit until the last part, okay? The main thing here, like with this example, don't worry about the limit. We're gonna keep the limit the last thing. We need to simplify what? The summation. So now, this one is going to be equal limit when n approach to the infinity. Now I'm gonna look to this summation. I can't do anything here with the 3i over n, but it's times the 3 over n. 3 over n is a number divided by the last term. Can I take it out the summation? So I'm going to say, okay, for this part, I can say, okay, it's a 3 over n summation from I equal 1 to n. And here is a 3 plus I over n. Now, what's the next step?
Separate them.
We're going to separate these two. So here is the limit. And here's the 3 over n. Open the bracket. I'm going to say it's summation from I equal 1 to n to the 3 plus summation from I equal 1 to n I over n. Now who's going to tell me what's the next step? I'm not going to do anything here. Here is the limit from n to infinity. I'm going to keep 3 over n. Here's the bracket. I'm going to write down this summation from I equal 1 to n to the 3 plus. I need to simplify this one. 1 over n. N is the last term. It's a number. Can I take it out? So it's going to be 1 over n. And here is summation from I equal 1 to n to the I. Now it's easier to work on. You see the limit? I'm just going to keep the limit until the last part. Now here's the limit from n to infinity. And here's the 3 over n. Let's see the first part. Summation to a constant. So it's going to be 3 times n. So here is the 3 times n. Which is 3n. Plus, I have 1 over n. And here, summation from I equal 1 to n to the I is going to be what? N plus 1 divided by 2. I can simplify this one with this one. So limit from n to the infinity. And here's the 3 over n. What's the left here? 3n plus n plus 1 divided by 2. Now tell me, what's the next step? What's the next step? What are you going to do?
Can we distribute the 3 over n?
Yes, you can. So it's going to be what? Can I do that? N plus 1 over 2 and 3n. Or can you make it easier? Can you add these two together? So if I say this is over one, see. Can I say this is over one? Can I multiply this one by two? And here is by two. So it's going to be limit. When n approach to the infinity. Keep this one. This one is going to be 6n over 2 plus n over plus 1 over 2. Now, can I add these together? Yes or no?
Yes.
N approach to the infinity. 3 over n is going to be 6n plus n plus 1 divided by 2, which is equal. Limit when n approach to the infinity, 3 over n, and here is going to be what? 7n plus 1 divided by 2. What's the next step now? Now, can you distribute? So it's the same thing. If you distribute, you have to add also, and you're gonna get the same result. So now distribute 3 over n, so it's going to be limit when n approach to the infinity. It's going to be 21n plus 3 divided by 2n. Yes or no? Because you're gonna multiply 3 with the top and n with the bottom. We done it from the summation. Now we have to take the limit. How am I gonna take the limit to the infinity?
You divide by the
highest exponent on the bottom. So you're gonna divide by the highest exponent on the bottom, which is
n.
n. That means the limit is going to be the limit when n approach to the infinity. 21 n divided by n plus 3 divided by n. And here is 2n divided by n. Cancel these. Cancel these. The limit for this one goes where?
0.
To a 0. That means what's the left on the top?
21 over 2.
That's it. See the connection we did with the using the summation and using the limit. Let's go to the next one. Now let's check what's the next step. I'm gonna start working on it.
Move the 2 over n
Okay.
cubed. Yep.
Move 2 over n cubed here. So I can say, okay, it's the limit when n approach to the infinity, 2 over n cubed. And here is the summation. And I equal 1 to n. Now, what I'm gonna do here,
Foil
just FOIL. So I'm gonna FOIL this one is going to be what?
or I squared
4i squared
minus 12i
minus 12i plus
9.
9. Be careful. Someone last semester, he said, okay, I squared is -1. Because he thought it's a complex number. It's not a complex number, so be careful. Did you plug in -1?
No, but I can see why he thought it was -1.
Yes, so be careful. It's not a complex number. It's index. Here it's an index, which is the first term here to the last term. Now, what's the next step? So it's gonna be the limit when n approach to the infinity, 2 over n cubed. Separate these with the bracket, so it's going to be. Can I write down right away? 4 summation from I equal 1 to n I squared. I move the 4i with the summation minus 12 summation from I to 1 to n to the I plus summation from I equal 1 to n to the constant. So it's going to be 4 summation from I equal 1 to n I squared plus summation from I equal 1 to n to the I plus summation from I equal 1 to n to the constant. So it's going to be 4 summation from I equal 1 to n to the I plus summation from I equal 1 to n to the constant. Next step is limit when n approaches to infinity. 2 over n cubed. Here is 4. For I squared is going to be what? N,
N plus one.
n plus 1, and 2n plus 1 over.
6.
Do we have n here?
Yeah.
You forgot the n?
No, you said N, so I said N plus one.
Okay. Mean it's n plus 1. We got it from this one, minus 12. That's the important part here when you simplify. Then n plus 1 divided by 2. And a plus for the constant is going to be 9. Now, can I simplify the 4 with the 6? It's going to be 3. That's mean it's a limit for n approach to the infinity. Can you distribute here? It's n squared plus, let's simplify this part. It's n squared plus n. If you distribute with 2n plus 1, how much does that? It's going to be 2n cubed plus n squared plus 2n cubed
Plus
n squared, that's right, plus 2n squared plus n. And there's going to be 2n cubed plus 3n squared plus n. Okay, so I'll simplify the whole thing here. That's mean the limit from 2 to n cubed. This part is going to be 2n cubed plus 3n squared plus n divided by 3.
would there still be a 2 on the
Oh,
other
2
side?
here, and you're gonna, okay, you're right, there's 2 here, so it's going to be 4, 6, and 2n. There's 2, so it's gonna be 4 here. Here is going to be 6, and this one is going to be 2n. Minus, simplify here, is going to be 6n, because we have here n squared plus n with the 6. So it's going to be minus 6n squared plus 6n and plus 9n. What do we do next?
Right.
For this side, you can combine. Okay, it's going to be 15n. And then how are we gonna combine this one with here? Two over n cubed. I have to do another step. 4n cubed. 6n squared. Plus 2n divided by 3 minus 6n squared plus 15n, because you can combine these together. I'm gonna write down this over 1. Now, how are we gonna get the same denominator? I have to multiply this one by, well,
3.
the negative. So negative, negative here.
There's 3N.
So maybe 3n.
You couldn't have just kept the negative sign outside?
Yes, but then you're gonna distribute it.
Oh, okay.
The negative sign, -6, when you distribute, like -6 times n squared is gonna be -6n squared. -6 times 1 is going to be -6. And there's going to be 3n. Now it's make more sense. The next step is what? You multiply by 3 to get the same denominator. So it's going to be limit. And approach to the infinity. 2 over n cubed. This one is 4 n cubed plus 6n squared. It's 2n divided by 3. And on this side is minus 18n squared plus 9n divided by 3. Now we can combine that terms because we have the same denominator. So it's going to be limit when n approaches to infinity, 2 over n cubed, 4 n cubed, 6n minus 18 minus 12n squared. And add these together, it's going to be 11 and divide by 3. Now what we're gonna do now, we're gonna multiply by distribute. So this one multiply by 2 and n cubed by the 3. So it's going to be limit n approach to the infinity, going to be 8 n cubed minus 24 n squared plus 22 n divide by 3n cubed. Then we're gonna take the limit to the infinity, so we're gonna divide by the highest exponent. So it's going to be limit when n approach to the infinity, 8 n cubed divided by n cubed minus 24 n squared divided by n cubed plus 22n divided by n cubed. Everything over 3n cubed divided by n cubed. The limit for this one,
8 over
because it's gonna cancel, so it's gonna be just 8.
8
Minus,
over 3.
Yeah, I
Oh.
got the same answer.
oh yeah, 8 over 3, you're right. 24, this one is going to be just n. 24 divided by n, take the limit is going to be what? 0. N cancel with n is going to be 22 over n squared. That means also is going to be 0 over,
3.
cancel these. So it's going to be 3. The limit for constant is constant. That means it's going to be 8 over 3. You got it? A little bit easier.